This is 5.3 day 1, solving trig equations. You don't need to write this first slide down. These blue topics are just some strategies to help you to solve for x. One of the things is combining like terms together. Like terms are going to be like trig functions, like a sine of x and a sine of x combined to 2 sine of x. Solve by undoing is going to be key here. Factoring, and then setting those factors equal to 0 and solve for x. Factoring with the quadratic type, those are going to be like trinomials, and you may need to use like the AC method or use substitution. Or converting everything to the same type of trig function. So maybe you have a sine of x in there and a tangent of x in there, and you want to convert it all to sines of x's or cosines of x's to the same trig function. So here's our first example that I do want you to write down. The unit circle. You should have that on your desk. We're going to refer to this a lot today to solve for x. I forgot that I had that in there. All right, so we want to find out what can x be in this equation. And our answer, we want it to be in an angle measure. And we're going to keep it in radian degree, not in degrees. So we say the sine of x plus the square root of 2 equals negative sine of x. So imagine if you were solving this equation for x, and just ignore that you even have any trig in there. If I say x plus the square root of 2 equals negative x, what would you do to solve that equation for x? Subtract square root of 2, okay. Then what would you do? You don't need to write this down. Add the x's, so you get an x plus an x. And then what would you do? 2x. And then what? Divide by 2. So you're undoing. That's what we're going to be doing today. But we have trig functions in there. And then at the very end, we're going to use that unit circle to solve for x. So we're going to do that same process. So I have the steps in the blue for you. We want to maybe push that sine of x to the left-hand side. So we add sine of x to both sides. So we get it in a standard form.
So we can actually solve it. Balance the left and right side.
Balancing the left and right side. No, you're trying to find out. You're trying to get that trig function by itself.
Trying to solve for x.
Trying to solve for x. Yep. But I made up a problem in this blue writing here that didn't have any trig in it. What would you do to solve for x? So we right now have everything over on the left-hand side. Then what would be the next step? Sine of x plus the square root of 2 equals 0. Add the sines of x's. Yep. Sine of x plus sine of x is how many sines of x's? 2 of them. Then what would you want to do to get the sine of x by itself? What do you want to undo? Minus the square root of 2. Get that square root of 2 over to the right-hand side. So how do you get the square root of 2 over to the right-hand side? How do you undo it? Subtract it. Yep. So now we have 2 sine of x equals negative square root of 2. What's the next step to undo? Divide by 2. Get rid of this 2. Well, this 2 is multiplying sine of x, so to undo that, we divide it. So now we have an equation that looks like this. The sine of x equals negative square root of 2. Now we're into chapter 4 that we did earlier this class. We say, when does the sine of x equal negative square root of 2? And we're going to focus on the unit circle again. Remember that unit circle does go on forever. So sometimes your homework is going to ask you to solve for infinitely many revolutions. And sometimes they'll just have you focus on one revolution from 0 to 2 pi. So your answers might look a little bit different depending on the question. So now pulling out that unit circle, when does the sine of x equal negative square root of 2 over 2?
225 and
315.
So those are you telling me in degrees. We would like you to leave your answers in radians.
Okay, so 5 pi over 4 or 7 pi over 4.
Okay. 5 pi over 4 and 7 pi over 4. There is this extra plus 2 pi n. The reason why is that unit circle that you have on your papers are 0 to 2 pi. But remember, if I add another 2 pi, I now have another coterminal angle that goes around, that wraps around. So my answer is x equals 5 pi over 4 plus 2 pi n, and x equals 7 pi over 4 plus 2 pi n. So it's just telling you that you can solve for more than just that first revolution for x. If you wanted to verify those truly were solutions, go back into the original question, back up here, and substitute in the angle measure both times, and it should be true. I'm not asking you to do that, but if you wanted to take extra time to truly see if you got the right answer, but that's what we're going to do today, is you're going to be solving equations for x. So that unit circle is going to become very important. Remember that unit circle is not allowed on any tests and quizzes. So for homework, they're going to be on your desk, but try to see if you can remember, geez, what is pi over 4? Well, that is this order pair and this order pair. Okay. So let's go on to another question. Next question is the secant of x minus the square root of 2 equals 0. We want to find out what can x be. So what do we want to undo first? Add the square root of 2. Now, on the unit circle has all those important ordered pairs. Those ordered pairs represent what two things in trig? Sine and cosine. Is secant on my unit circle?
No.
No. So what might I need to do first? Use its reciprocal identity. And what's the reciprocal of secant? Reciprocal of secant. Yep, 1 over cosine. So to be able to convert it to a cosine of x, I have to reciprocate my secant right side. Now is that on my unit circle? Is 1 over the square root of 2 on my unit circle? No, it's not. So what's so important about radicals and denominators? What did we always do for you guys?
The radical numerator.
Yes, and what do we call that fancy words? Rationalizing the denominator. So we have to multiply the numerator and the denominator by the square root of 2. We have to take this and multiply by the square root of 2, and that by the square root of 2. And what we're left with is the square root of 2 over 2. Now that benefits us to now use that unit circle. What angles would give us the solution for the cosine of x equaling the square root of 2 over 2?
Pi over 4.
So think about your quadrants too. What makes sense? Cosine is that x value. So you don't need to write this step down every time. This is just identifying that it's inverse trig. So where on the unit circle do you get the cosine of x equaling square root of 2 over 2? Pi over 4 and 7 pi over 4. And then if you're talking no restriction on its domain, then you would add in that plus 2 pi n to the end. So you're understanding that there are more solutions than just that first revolution. Stop recording.